Yeah, hello everybody. So today we are going to discuss the problem of today of gigs for gigs. The question is tree transformation. So as you know in the question, we are given a tree containing n nodes in the form of an array P, where Pi represent the parent of ith node. And since we know that the zeroth node is always the root, so its parent is -1, means it does not have any parent. So we have one operation which we can perform is that we can merge any two adjacent nodes. So we need to perform this operation minimum number of times so that we can convert this tree into a star tree. Star tree by the name suggests that there would be a center node and all the nodes would be connected to the center node only. Yep. I hope the question is clear to you all. So moving on to the example, there are a few examples. One is number of node is 5 and this is the parent node array. -1 indicates the node 0 which does not have any parent. Parent of node 1 is 0. Parent of node 2 is also 0. Parent of node 3 is 1. Parent of node 4 is 1. So the output is 1, means on performing single operation. What operation? Merging operation. That on merging of two adjacent nodes only one time, this tree will convert into star tree. So let's see what they did. So they merged 0 and 2 together, forming a single node. Either it's 0 or 2. So we can see this is a star tree with the center node as 1 and adjacent or the corner nodes are 3, 4 and 0. So yeah, and second example, if we see the given tree is in this format. So as you can see, they merged 5 to the 2 in the first step, resulting in this, and then they merge 2 and 0 resulting in this. So this will become a star tree in minimum of two operations. So as you can see from the first of the example and the second example, both are not related to each other. Like in the second example, if you see, we are given a basic hint that if we merge any middle parent, or we can say inside node, the middle one, then that will result, means all the children of that node will automatically got merged or attached to the upper node. So um, that will result in the star tree which we want. If we can see, like 5 is merged to 2, 5 is a middle node and it's merged to 2, and again the 2 which is the middle node, because 1, 3, 4, 7, 6 are the leaf node and 0 is the root node. So we are considering only the middle node. 2, which is the middle node, is merged to 0, results in a star tree. So the approach we got is that we can, at a time, always we can recursively go on merging the middle nodes. So in this example, if you see, then 2 is a leaf node which is merged. Okay, so here they are merging leaf node, but what if they merge the middle node, that is 1? So then also with one output, sorry, with one move, they can convert it into the star tree as shown here. This is similar to 0, 1, 2, 3, 4 is given 0, 1, 2, 3, 4. So we can merge 1 to 0 so that 3 and 4 both will get attached to 0, then resulting in this tree. As you can see, 0 is now attached to 3 and 4 and 2 is as it is. So what happens is that our approach of merging the middle node recursively worked here, and it got converted to the star tree with the center node as 0 and all the other nodes are the adjacent one in one operation. So the basic logic we can find out here is that we can recursively go on merging the middle node 5, 2 and 1 as shown in these two examples. Now, the thing is that we need to figure out how many middle nodes we need to merge here. So for that, we need to write the code here. So we are using a set S, and we are inserting all the middle nodes. As you can see, if the value of the vector is -1, that means it's the root node, that is 0. And if the value is 0, means it is the leaf node, such as 1, 3, 4. 2 is also containing the value as 0. So but later on the 5 and 6, which indicates the pointer to 2. So they will insert the value of 2 in this s. Suppose for first example, if we see, the s will contain, for the first example, s will contain 2 comma 5, right? Using a set, basically it contains unique value. So 2 comma 5 will be the unique value, because we are not inserting minus 1 and 0, else we are inserting all the values, so 2 and 5. So as we can see, s contains all the values which are the middle node, which we need to remove. As you can see from here, we are removing 2 and 5 in two operations. So mainly two, if there are two nodes, then we require two operations. For this example, if you see, s will contain only one, because 1 and minus 1 and 0 will not be inserted and 1 will be inserted. So s will contain only 1, and since the size of s is 1, means there is only one middle node which we need to merge. So we can finally return the size of s, that will result in the minimum number of merging operation we need to perform. So this is the C++ code. If you want the code in Python, then you can also use the dictionary in the Python, or the set in the Python, and also you can use hash maps in Java. We can also solve this using map in C++ as well. Hope you like the solution. So let's meet in the next solution for the problem. Thank you.